det sagt så tänkte jag kicka igång här med att introducera vår första talare. Och det är Stephen White. Och han ska nu ta oss med till en framtid där spinners och nätverksbegränsningar är ett minne blott. Han kommer visa oss hur så kallade local-first-appar kan skapa en sömlös och blixtsnabb användarupplevelse. Och detta helt utan att använda sig av API:er. Och han kommer göra detta med hjälp av konkreta exempel. Och det är då Cadec-appen som nyss nämnd då, kommer att visas. Så med det sagt tror jag Steven ser redo ut här. Och jag ber om en varm applåd för Stephen White.
Thank you, Andreas. Excuse me. Give me a second. I just need to quickly get my mobile connected here. But in the meantime, if you haven't downloaded the Cadec app, here's some QR codes. The first one's to the App Store and the other one's to an APK file, which I wasn't able to get out into Google Play Store in time. So if you can trust us, then download it if you're on an Android phone. If not, then just bear with us. But right, just a minute. Let's see if I can do this. The screen is so huge. Oops, you don't want me. Here we go. Right. Great. Fantastic. Okay, so first of all, I've redone the app. If you were here last year, you saw the conference app that I did then, which I'd done in Kotlin. And this time I've done it in React Native, which is kind of like bread and butter for me. And I kind of feel at home. So, yes, first of all, I just want to, let's just have a quick look at it. So you can see we've got the program Göteborg, and you can see the speakers. So there I am, I'm at the top. And there's a little question mark there, which you can click on to ask a question, or you can click on the talker and you get the question mark there, which you can click on. So, and then you can ask a question. So will local first replace the BFF, back end for front end, that is. And I send that in. Okay, and you notice that it's kind of grayed out, but I can still interact with it, the question. And any second now, okay, come on. Dun, dun, dun. We should get a reply from the AI service. Okay. That's a bit slow. Okay, let's go back. Okay, let's ask the question again. That wasn't very good, was it? Okay, will local first replace the BFF? Do this one more time. Hang on a second, it could be because of my network, which is interesting. So I'm going to turn off Wi-Fi here. Let's do this. We got an answer. Okay, great. Okay, there was a bit of a network problem there. But you saw that I was still able to interact with the question. So if I click on the question, we've got our response from the AI service, which my colleague Andreas has created. And so maybe Andreas wants to quickly talk about that.
Yes. Not sure about why it was so slow there, but anyways. A quick interlude from me here and the background behind this AI service. We thought about this, jag kan prata svenska istället, inser jag nu, redan förra året, och det var ju att varför inte använda AI för att moderera frågor? För det var en rolig tillämpning, och en frågeställning då som vi utgick ifrån var skulle vi kunna använda AI till det här? Och frågan som vi vill lösa, eller problemet vi vill lösa, det är ju just att moderera frågor. Och då kommer vi fram till följande lista med features, eller uppgifter som den här appen har då. Och det första är då att filtrera bort dåligt språk, och det kan man faktiskt göra ganska enkelt rent programmatiskt med en ordlista av tråkiga ord. Men det svåra sen då, som en LM är väldigt bra på, det är ju just frågan att lösa ut, är det här en relevant fråga i relation till ämnet? Och sen kan man ju även få ett annan bonusinformation, liksom vilken ton, vilken stämningsläge frågeställaren har. Och även faktiskt på köpet även få ett litet kortfattat svar. Och ni kan se de här sakerna i appen då. Och ni kan ju roa er med att ställa off-topic frågor då, liksom är chokladglass godare än jordgubbsglass till exempel. Får ni se vad som händer. Ja, så sagt och gjort. Vi gjorde en implementation och det är ju relativt simpelt faktiskt att använda en LLM. Det krävs egentligen en API-nyckel och ett kreditkort och förmåga att ställa en HTTP-fråga. Eller en fråga över HTTP. Sen är det ju lite runt om då. Det knixiga är att få till ett upplägg med en bra prompt. Det här är ju AI Inference. Vi använder en förtränad LLM-modell här då. Så lösningen ser ut så här. Tjänsten ligger som en AWS Lambda. Och den använder sig något som heter structured output med hjälp av LangChain JS i det här fallet. Så det är en TypeScript-baserad implementation. Och så beror vi på OpenAI och deras API då. Så om vi går till nästa bild. En annan feature med LangChain då, förutom att man har väldigt smidig abstraktion ovanpå klienter, är just det här med structured output, hur man hanterar det. Och även förmågan att kunna skifta eller lämna implementation på ett smidigt sätt när man utvecklar. Och det är något som jag har med mig av här då, just utvecklingsskedet, att kunna ersätta OpenAI med en vald modell, bland annat via Olama till exempel, om man kör lokalt på sin maskin. Här skulle man ju snabbt kunna slänga in DeepSeek om man skulle vilja det till exempel. Yes, med det sagt så går vi vidare till huvudpresentationen.
Yep.
Tack så mycket.
Thanks, Andreas. Thank you. Okay, so I'm going to start from the back and maybe work my way forward here. But let's just have a quick look and see how all this works, or how all this fits together in the app and also in the back end. So first of all, you ask a question. So, and then you have this sync engine which synchronizes the question to the back-end sync engine, which in its turn will insert it into like the main Postgres database, which is up in the cloud. And in this case, I'm using something called Superbase. Okay, then there's a trigger on the insert in the Postgres database, which then calls the moderator service. And then that obviously calls OpenAI. And then we get an update from the moderator service, which is the reply, which comes into the trigger, updates the particular row in the database, and then that row is synchronized back to the clients. So all of you guys, so all of you who are looking at your telephones, this is now synchronized back to the telephone. And when I say synchronized, it's synchronized to a local database. So I'm using SQLite, which is locally in the app. And then you can see the response in the question. And if it was a good question, then it's okay. But if not, then it was bad and it's not okay. So you'll probably see a little red title or something if you're being naughty. Anyway, right. So that gives you the whole kind of structure. So keep that in mind as I go through the presentation. Okay. So local first. So local first tries to give us a whole bunch of things. The first thing is collaboration, ownership of data, and there's some local first ideals, which I'll get to in a sec. But one of the really cool things is that you can work offline, and then you can collaborate with your colleagues. It provides security, privacy, long-term preservation of your data, and also user control of your data. But first of all, the local first ideals, which were created by a company called Ink and Switch. And there's a couple of well-known people, if you're in the front-end world, Peter van Hardenberg, and also Adam Wiggins. And these people come from Heroku, so if you've used Heroku, you've used their services that they've created. But they jumped off of Heroku and started Ink and Switch with a guy called Martin Kleppmann, who's a doctor at Cambridge, focusing on local first. And they had a bunch of ideals that they wanted to achieve. But first of all, actually, also, I'll just quickly mention Johannes Schickling, who runs a podcast called Local First FM, which you can get to if you scan there. So if you want to find out more about Local First, I really suggest you go and have a listen to his podcast. But I think one of the things that Ink and Switch did is that they created a rallying call for developers to work behind, because local first has been around for ages. We've all been using, say, Apple Notes, GoodNotes, Figma, for example, Miro. Have you ever wondered how cool it is that all of your colleagues appear in Figma as you're looking at Figma? Or even if you're doing a retrospective in Miro and all of a sudden all your colleagues can vote and do this stuff. All of this is local first technology. But the thing is that all of these big providers have been sitting on their own proprietary synchronization mechanisms. But Ink and Switch tried to kind of define what it is, giving us developers a way of kind of work towards, if you like, as opposed to reinventing the wheel, if you like, and also the Cadec app. So they had these ideals. So the first one is no spinners. It should be fast. Instead of 60 frames a second or, like waiting for a couple of seconds, it should be like, 10 milliseconds. It should be per frame rate. It should be that fast. And using SQLite, you can actually get to that speed. I mean, in Apple Notes, you never wait. You just type and, it synchronizes in the background. Your work is not trapped by one device. So everything you write, everyone else here can see. So in a way, your work is being shared by all the people who've got the Cadec app at the moment. But also, again, coming back to Apple Notes, you can type your note and then all of a sudden it magically appears on your Mac. How many people have wondered about that? How that happens? No one? Okay, right, let's continue. I asked my kids that question and they were like, well, it just sort of does it, doesn't it? They just expected it. The other thing, the network is optional. You should be able to work offline. So actually, my little mistake at the beginning of the talk was maybe on purpose, because I was kind of offline when I was asking the question. I could still see the question, but the response hadn't come back and the synchronization hadn't happened. But you can still work with your data, even if you're offline. And then once you're online, it then synchronizes. So seamless collaboration with your colleagues. Your colleagues appear in Figma, for example, or Sketch or something, and you can collaborate with them. The long now and longevity. Now, this is a picture from the Dark Ages, and it's been said that what we're living in at the moment is an IT dark age, in the sense that the Dark Ages weren't dark because it was really black in the 1300s and there was no sun or anything. But it's dark because there's no records of what happened, or a very minimal amount of records of what happened. And it's been said that actually what we're going through now in the IT business, especially with cloud computing, is that a lot of the stuff we push up to the cloud has no longevity. It will just go. If the cloud is turned off, our work vanishes. It's not there. So, in a way, what's going to be remembered more in our IT epoch is probably something like Doom or WordPerfect, where you had this stuff on a disk. This probably has more longevity than some of the stuff that we're doing in the cloud, which is great because I love playing Doom. It's one of my favorites. Security and privacy by default. I won't say too much about that, but that's one of the ideals. And you retain ultimate ownership and control, so user control. Even though maybe the stuff is synchronized to the back end, you still have control. If you remove your data from your device, it will go. So these are ideals, and these ideals aren't there to be all fulfilled. You could maybe do like the first three, no spinners, working offline, etc. But it's not, you don't have to do all of these to achieve a local first experience. I think if you can just get rid of spinners, that's a really, really good start, to be honest. So, where are we now? So, we're still dealing with request and reply. That is what most of us are doing when we're creating applications. We have REST or GraphQL or something. And there's huge innovations, both in the front end and in the back end. You know, in the back end we have Kubernetes, for example. We have Lambdas. We have, you know, a plethora of cloud services. In the front end we have React, Svelte, you know, et cetera, et cetera. You know, we just have all of this amazing stuff that we can work with, but something is missing. So the thing that is missing is the sync engine. So local first suggests that the sync engine is like the next step forward in our kind of evolution as of creating apps. Now, what does it solve? It mainly solves how we shuffle data around the system. You know, how data is moved from the back end to your app. It solves merging. Okay, and this is mainly kind of handled by something called CRDTs, or conflict-free replicated data types. I really don't want to go too much into this because people have written doctorates about this subject, but in short, it's a data type, and the conflict-free part of it is the merging algorithm. It's the thing that is merging your data. So it can be a conflict free replicated data type for, say, JSON data, sets, primitives, any kind of data type that you can think of. But it magically handles the merging process. So, I mean, if you use Git every day, you probably think, well, hang on a minute, you know, like when you get a merge conflict, you know, how can you just magically merge this? You know, it takes quite a lot of effort to sometimes merge conflicts. But this is what the effort of CRDTs is doing at the moment. So there's a lot of, it's not 100% fixed, but they're moving forward, and there's a hell of a lot of research, and there's a hell of a lot of companies who are working with this. So in my little example, I'm using something called PowerSync, which is the this icon down here in the cloud. So how does this work? Well, first of all, you connect to a Postgres database, for example, and you have a replication log, which you can hook into. So the sync engine hooks into that, and it creates snapshots of that data. So this data may be huge, you know, maybe it's a data lake, or maybe it's a huge Elasticsearch cluster or something. So you just want to expose small chunks of that data to your clients, if you like. So within the sync engine, you define something called sync rules to be able to do that. Then thirdly, you'd have a sync engine on your device, on your telephone, which is basically responsible for synchronizing the data from the back end to the device. And then this local sync engine will sync onto the local database. Sorry, I'm getting a bit of feedback here. There we go. Okay, so a sync engine. You can think of a sync rule as a materialized view. You know, it's like a small chunk of the data that you feel you're going to need for your front end, or for whatever consuming applications are going to be consuming that data. So it comes in a couple of variations. The first one is data queries. So for example, you know, I've got a sync rule that just selects everything from the questions table, you know, with the Cadec-app, for example. So that means that all the questions come down onto the app. But then also you can have parameterized queries. So the usual use case for this is like a user ID. So with Supabase, for example, which is a cloud-hosted Postgres service, you can have security and you can have, JWT tokens, for example. So it's a way of demarcating your data or splitting the data up on a user basis, if you like. But obviously you can do this on any parameter that comes in the sync rule. And obviously you would end up with a bunch of different buckets, one for user 1, one for user 2, for example. And it's a way of kind of splitting up what data is fed back. So, traditionally, maybe you would just have a REST endpoint where you're just getting data straight from your platform. And then, maybe you've incorporated some kind of BFF where you don't want all of this data from the platform, but you just want to stream over some of that data into a BFF database. But again, you've still got the request reply thing going on between the front end and the BFF. But this is a kind of a common pattern. This is something that I did quite a lot when I was working at Volvo Cars. But instead of the request reply, you can just replace that with local-first, with a sync engine. But it gives you an idea of like maybe how you could do this, if you're dealing with a lot of data. So how did I choose the tech stack? Now, one of the problems is that the market is very young at the moment with local first, especially in React Native or within a TypeScript environment. So there's a bunch of different libraries. There's a library called Electric SQL, which is very good. TinyBase, PouchDB, if you're using like a document-based database. Then you have different ORM tools, so object relational mappers, Prisma, Drizzle. There's a whole bunch of others as well. So this is basically Hibernate for JavaScript or for TypeScript, if you like. And then there's a whole bunch of different sync engines as well. At the bottom is PowerSync, which is what I'm using. I kind of ended up with PowerSync because they have a really great free tier, so hopefully this isn't going to cost me anything. So don't ask too many questions, okay? And then at the top you've got AutoMerge, which is what comes from Ink and Switch. And that's used in Linear and also in GoodNotes. So if you're using GoodNotes, then you're using this technology already. So I ended up with Expo, Drizzle, ORM, PowerSync, and Supabase. And all of these things kind of worked really well together. So Supabase, Postgres, PowerSync, and Drizzle for doing my ORM-based queries. And it's all wrapped up in Expo, which is React Native. So what kind of developer experience have we got? Sorry, I just have a quick drink. I would say in general, it's pretty much the kind of developer experience you would get if you were just working with a database, plus, working with the front end, if you like. But you kind of skip the API, okay, which is both nice and maybe not so nice, depending on where you come from. But first of all, you define some kind of schema. So I'm using Drizzle here to define the schema. And it's just, you can do this in raw SQL, but I chose to do this in Drizzle because I'm kind of lazy, I guess. So you define your schema for the back end. Then there's the migration and the seeding of your data, for example. So Drizzle comes with a bunch of commands for you to be able to do this. And seeding of the data is basically just grabbing the data in JSON and just inserting it or deleting it, depending on how you want to seed that data. And then in PowerSync, so that's your backend database. So you've defined your schema, you've seeded it, set it up, and then in PowerSync, you create your sync rules. And you can see here I'm being pretty open. I'm just selecting everything because that's the nature of the Cadec app. It's an open app. But if it was much more user specific, I would be using these parameter queries as I mentioned earlier. Then we have the client. Okay, so again, I'm using Drizzle, so I'm using this for both the back end, for the main database, but also the client. And you can see here that, we're using an SQL-Lite dialect, and you can create basic tables, but also you can create relationships, which is really nice. So locations to talk is quite kind of complicated because it's a many-to-many relationship. But it just gives you an idea that you can basically create anything that you would do with SQL with this. So once you've done that, you then create your hooks. So you want to hook into this data, if you like. And the really cool thing with this is that you have reactive queries. So that use query hook, whenever anything changes in the database, it reactively updates your view. So just like in Redux or MobX or any other state management, or if you're using a context, for example, whenever the data changes in the database, it updates the view. And this is the magic of everything. Because you have a complete reactive system, both in the back end and in the front end, which is totally awesome in my mind. So you can see I'm just firing off a find first query for the particular talk in this example. But then you can do aggregations. So if you want to do a vote count, you can use count, which is a drizzle function. But then if you want to go really crazy, you can do your own SQL. So you can inject your own SQL into the use query hook. So for example, on the questions list in the app, there's loads of subqueries that are firing off for vote counts, for example. And you can do this. So you can do whatever you like, which is very cool. And then mutations. So these are basically insert statements. So, when you create a new question, I just insert it. So, if you're used to using SQL and if you're used to running with RDSs, this just feels at home in my mind. It feels very straightforward. And then finally, you just use the hook in your component. So, use insert question, and then I get back the insert question function, which I can then call with a question, or if you want to get your talk, just use talk and pass in a talk ID. So it's just nice. This is all I need to think about. Okay, so final thoughts. I think one of the things is that I really love the fact that it's amazing DX. I found that I could iterate in the back end and in the front end at breakneck speed. And this was really nice for prototyping because you can just prototype going directly against an SQL-Lite database, and then you can move that schema definition directly to the back end if you want. So if anyone's ever done Ruby on Rails, it's kind of that kind of feeling. You work with your database and then you just get the data you want for your views and things. So I just found that great. It reduces cognitive API load. So sometimes when you're working in a front-end application, it's like, okay, great, there's the view. I need this data. You go back to the back-end team, and they're like, well, this is going to take 6 months to get the last name filled in this query. And you're like, oh, okay, right. So I just really love the way it kind of you skip the API. I mean, obviously, this is a BFF thing, so I'm not saying skip the API completely, because if you are exposing an API as a platform, then that's great. But I think from a front-end perspective or from a consuming perspective, it's really nice to have that control over the data that you're getting. So again, the domain is king. We come back to working and looking at the domain and looking at how the data is connected. Which sometimes, if you're dealing with REST APIs, can be really, really tricky to see how everything is connected. Everything is reactive, including from the back end to the front end. And this is pretty amazing. And it's very new. There's a lot of libraries out there. There doesn't seem to be a golden path to take at the moment. So you can be a pioneer here, which is both exciting and scary. But it means that you've got a chance to move forward with some pretty cool technology. Just try it. I really, if you've got an app or a front-end application that is plagued by spinners, and your product owners are constantly tired of you fetching this data, then just give this a try and just see how you feel. So from a con, the pioneering tax. Obviously, that's a scary thing. It might not be a good match for all apps. I don't think it is, to be honest. It can be hard to find a tech stack that suits your needs at the moment because there's just so much to choose from. So if you do it, then maybe just go to a blog and choose something that's kind of already defined, and then you can work your way out from there. So with that, I'll publish this so that you can get the code and you can see how this is all put together. But I just really love the way that declarative queries kind of clarify the application structure. And I think that managing all the state in one place kind of leads to a bit more flexibility. And I just think you get a much more cleaner mental model. Okay, thank you very much.
Tack Steven. Då är det frågestund, Q&A, och det har trillat in en massa frågor. Och då tar vi dem givetvis i ordningen som de har fått röster. Ska vi se om vi synkar det? Ja, 19 har jag också på min mobil här. Mycket bra.
It should be synced.
All right.
Oh my God.
Då kör vi första frågan då. Which type of apps are appropriate for local first?
Oh dear. Okay. Well, the Cadec-app, I think something where you're collaborating is definitely number one for local first apps. Maybe something like Facebook is a bit too vast, I would say. And, if you're doing like an ATM application, that's probably not so good.
No.
No.
Nu vet när man kan gå in och kika på om Steven famlar eller om han har korrekt svar här nu då, genom att titta på vad AI har svarat. Och det kan vara såklart det omvända, att AI famlar, så att vi får se här. What are good pattern strategies for handling conflicts when synchronizing the local data with the backend?
Well, the thing is that this is something that you shouldn't have to worry about so much, because there's a lot of very, very smart people who are working on these CRDTs, as I mentioned earlier, and the merging of data. So, to be honest, this is something I really didn't have to think about, and I was very happy about that. In my current application, we have synchronization mechanisms, and the code there is good, but it's complex. And so it's one of those kind of areas that, a lot of developers don't want to go into. So I'm really happy that there's a lot of smart people sorting this problem out for me. Yep.
Yeah, thanks. Then a question about management and migration of the data model. How do you handle SQLite migrations when in regards to app updates? So the development of the data model.
Well, the thing is that the master data model, as I showed earlier, was actually the back-end database, or the database that you're. Oops, what's going on? Is the database that is then synced to your SQLite database. So all of that migration stuff happens in the back end and is then pushed out to the local SQLite databases. But I think it's a bit like if you've used GraphQL, for example, it's much more of an additive sort of process. I think if you remove columns, for example, or fields, then it becomes very problematic. So it's something that you have to add and then maybe deprecate under time. But I'm not 100% sure about that just yet, actually. So that's something I'm going to have to look at more.
Mm-hmm. Yeah.
Yep.
Let's see. Now it's moving up and down the list here. But how does local first handle connection issues with the hopefully few services which aren't local? Challenges, opportunities? Question mark.
Again, I would say I just use the sync engine to do this. This is something I didn't have to think about. But I think it's probably something that you will have to think about at some stage. But in the Cadec app, it's PowerSync, which is taking care of that stuff for me. Yeah.
Yeah, yeah.
But that's maybe a bit of a naive answer, to be honest, but never mind.
Mm. Then a bit, I wouldn't say off topic, but a little bit outside the box. GDPR, how do you think in regards to that? And that's mainly regarding other users' personal data.
Well, the Cadec app is probably not a great example of that. I mean, there's no personal data stored on there apart from your questions, which are shared with everyone. But I think, I mean, in a normal situation, you'd actually have to log in to the app. I didn't want you to log into it because I just thought we would get less retention of the app. But once you've logged in, you'd only see your data, unless it was public data. So hopefully there'd be some kind of demarcation around that.
Mm-hmm. Yeah, I mean, this is just a technology. GDPR is still relevant regardless of how you implement your app, obviously. Okej, vi har tid för en fråga till, eller kanske två till med. Will local first replace the BFF? I think that's your question.
Oh, is that my question? Yes.
But maybe you can elaborate on that, because it's interesting.
Yeah, yeah. I mean, I've been working with BFFs for years now, starting from REST or starting from server-side generated web applications to REST, to GraphQL, and now this. I got to say that I was getting a bit bored with my daily work because of the usual kind of API issues that you encounter as a front-end developer or even as a back-end developer, and I just really like the way I could just stop thinking about the API and just think about what data I wanted to fetch. In a way, the SQL queries were very similar to what I would imagine a GraphQL query would be. I was kind of thinking in that kind of mindset, just selecting the data that I needed, for a particular view or for a particular component that you would do in GraphQL. But yeah.
Yeah, great, thanks. Big round of applause. That's all we have time for now.